What if I told you that there is one machine on Earth that decides whether your country is allowed to build advanced chips at all? Not a company, not a factory. One machine made by one company in one small country. And for the last 30 years, if you couldn't buy that machine, you simply were not admitted into the modern world. Last Monday, a factory in Shanghai started building its own. Within hours, ASML, probably the most untouchable company in technology, dropped 8%. Samsung and SK Hynix posted their worst sessions in decades. Korea's market went into freefall. And I think almost everybody read this story wrong. So let me show you what actually happened and what actually broke. All right, let's start with how a single piece of equipment got this much leverage over the world economy. Because it's genuinely strange when you sit with it. Every advanced chip starts life as a blank silicon wafer. To turn that wafer into a processor, you have to print a pattern onto it. Billions of features measured in nanometers. The machines that print that pattern are called lithography systems, and they are, without much competition, the most complicated objects human beings manufacture. One costs well over $100 million. The most advanced ones ship in dozens of freight containers, and exactly one company makes them, ASML in the Netherlands. Not the market leader, not the dominant player among several, the only one. TSMC, Samsung, Intel, every serious chip maker on the planet buys from the same Dutch supplier. There is no second option, and there never has been. Which is exactly why lithography became the pressure point in the entire US-China technology fight. You don't need to ban chips if you can ban the machine that prints them. Ban that, and you get to set another country's ceiling for them. Every export control written over the past 6 years has been built around one company's catalog for precisely that reason. Now here's the bit I think is beautiful, and it's also the bit that explains why this was supposed to be impossible to copy. The light inside these machines has a wavelength of 193 nanometers. The features they print are far smaller than that, which should not work. You cannot normally draw a line thinner than the tip of your pencil. The trick is water. You flood the gap between the final lens and the wafer with ultra-pure water. Light bends harder in water than in air. Higher refractive index. So the same 193 nanometer beam resolves a much finer pattern. That's immersion lithography. It is the single reason the entire industry got past the 45 nanometer wall. And it's the exact category of machine we're talking about today. And the engineering wrapped around that idea is close to absurd. The wafer stage accelerates harder than a fighter jet while holding placement accuracy in fractions of a nanometer. Water flows through a moving gap continuously without ever forming a single bubble. Thousands of wafers a day. For 10 years. Without drifting. That's the thing to hold on to because it explains everything that follows. The physics here is published. Anyone can read it. The physics was never the moat. The moat is doing it 10,000 times in a row without a defect. So, July 27th, reports come out that a Shanghai company has begun low-volume production of its own immersion DUV systems. And here's where most of the coverage got sloppy. So let me be precise, because the detail is the story. The company is Shanghai Aishengna Electronic Technology Group, founded August 2023. Roughly 7 billion yuan, about $1 billion, in registered capital, backed by Shanghai Electric and a Shanghai International Trust subsidiary. But the important part isn't the money, it's who's inside it. Aishengna absorbed the engineering teams of two separate organizations at once, Yuliangsheng, the Huawei-linked Sci-Carrier affiliate, and SMIC, China's original state lithography company, which had been grinding away at this problem for 20 years and mostly failing. That's not a startup. That is a state-directed decision to take every lithography engineer in the country and put them in one building. The machines print 28 nanometer features in a single exposure. Run the wafer through repeatedly, multi-patterning, and they can reach towards 7 nanometer class chips. First customers are SMIC, Huahong, and CXMT. 5 machines this year, around 20 next year. Okay, I want to be upfront here. Because the market reaction and the actual news are two different stories, and I'm not going to pretend otherwise. ASML ships about 130 immersion systems a year, roughly 11 a month. China's plan is 5 for the entire year. That is a 26 times gap, and even hitting the 2027 target only narrows it to about 8. And volume isn't the hard part. JP Morgan put it about as clearly as anyone. Building an immersion DUV tool is not the same thing as high-volume manufacturing, where yield, overlay, throughput, and reliability across thousands of wafer runs are what actually count. Reporting also notes some critical components are still sourced from Japan, so domestic currently carries an asterisk. The best analogy I can think of is this. Building one working machine is like cooking one perfect meal. Running a chip fab is like feeding a city 3 times a day, every day, for a decade, and never once making anybody sick. Those are not the same skill. The first one is engineering. The second is years of accumulated, boring, unglamorous competence, and it cannot be bought or rushed. And one more thing. This is DUV, not EUV. The top tier, the machines that print the actual leading edge, remain ASMLs alone. That gap is far wider and far harder to close. So if the near-term impact is that small, why did a continent's worth of chip stocks fall in a single session? Because markets don't price what's true today. They price direction. And there's a number in ASML's own reporting that says more than the stock chart does. China was 33% of ASML's revenue for full year 2025. In the first half of 2026, it was 16%. That's not a forecast. That already happened. China stopped being ASML's largest customer before this machine ever existed. And now we know where that money went. That's the part I keep coming back to. The controls were designed to deny China the machine. What they actually did was convert China from ASML's biggest customer into ASML's only competitor. You cannot deny a country a technology and keep selling it to them at the same time.